one problem. So from this problem is cascaded amplifier. So from this problem we are going to identify how did you obtain that overall gain of your given amplifier. So here we are taking as the amplifier is a BJT amplifier. I am taking two BJT amplifier. So by using these two BJT amplifier, we have to know that how did you obtain that required output. Okay. So this is that problem. They are given. The problem is a cascaded amplifier. Will you please look into that diagram? They are given two transistors. One is Q1, another one is Q2. Okay. So they are taken as a NPN transistor because the arrow is inside. So NPN transistor, right? So this is only we observe from the diagram, and they are given one supply is VCC, and one more input source voltage is given is Vs, and one input resistance is connected to the base of your Q1 is 1 kilo ohm, and the collector of your first transistor is 10 kilo ohm, which is connected to VCC. Of your first transistor taken from collector, but collector having that internal resistance is 5 kilo ohm for the second transistor, and we are going to observe the output from your collector terminal of your second transistor Q2. So these are the parameters only we will observe from our diagram. They are given the statement, find the voltage gain. Voltage gain means A suffix V. They are given A suffix Vs. Vs means total overall voltage gain, the output of the entire output of this cascaded combination. Then AV1 was only the voltage gain of the first stage. AV2 voltage gain of a second stage of the cascaded amplifier. And they are given the H parameter values are given. The H parameters is nothing but input impedance, output impedance, forward impedance, and reverse impedance. Okay. So E is mentioned as emitter base. That's why they are taken as like that. So HIE is 1 kilo ohm. HRE is 10 to the power of -4. HF is forward is 50, and also output impedance H0 of E is 10 to the power of -8 ampere per volt. So these are the values are given. Only the 4 values are given, and some of the resistance values also in the diagrams they are mentioned, and they asked to calculate only the 3 things, that is voltage gain of first transistor, voltage gain of second transistor, and overall voltage gain. So we have to calculate. And will you please look into the diagram again? From these two transistors, I will come to know first transistor is a common emitter configuration. First transistor is a common emitter configuration. So emitter is a common terminal between input and output. It's a common emitter configuration. Output usually will taken from the collector terminal. And will you please look into that second transistor is a common collector because we have taken output from that collector terminal. So it's a common collector. So Q1 is common emitter, Q2 is common collector. So this is their things we have to observe from this transistor. They haven't mentioned. So these are things you have to observe from the given problem. Voice is audible. Screen is visible.
Yes, sir.
Then now we are going to start to solve the problem. The second transistor Q2 is a common collector. Yes, I said earlier they are given the statement. Second transistor is a common collector configuration. Q1 is the first one is a common emitter configuration, right? So it is convenient. We will start from that stage 2, second transistor. We are going to solve the problem from the second transistor itself, right? So first one is what we are going to calculate. We are going to multiply these two values. Their values are output impedance. H0 means I am going to call it as output impedance. Easy way to understand output impedance, and product with the load resistance of your 2. So load resistance from the diagram you will come to know that is 5 kilo ohm. That is the load resistance. Here they are connected. No, that is RL2. Yeah. So that load resistance and that output impedance. So product of these two values you are going to get some that is nearly equivalent to 5 into 10 to the power of -5. That value it is less than 1. So this only we are going to observe while product of output impedance is that load resistance 2. We are going to get the values. That value is which will be less than 0.1 because you will be getting 0.0005. So that is less than 0.1. So if it is less than like that, we are going to calculate R suffix I2, that is internal resistance to second transistor, internal resistance for your second transistor. Ri means internal resistance, 2 means second transistor, internal resistance of your second transistor. So why we have to find this one? Because that voltage gain will be calculated with the help of output voltage divided by input voltage. Here output voltage we don't know, input voltage also not a given. So that another way to calculate the voltage gain is, they are given 1 minus Hi divided by Ri. Okay. So 1 minus Hi means internal impedance is given. Okay, internal impedance they are given in the problem itself. That is, I think 1 kilo ohm. Internal impedance is 1 kilo ohm. That is given. But Ri is we don't know, because the second stage we are going to calculate voltage gain. So Ri2. If it is first stage means Ri1. Right. Okay, if it is Ri2 is a cascaded combination, so we have to calculate this is an unknown parameter. So first we have to calculate the unknown parameter Ri2. Ri2, how can we calculate Ri2? Ri, which is a easy way to calculate, Hi internal impedance plus sum of 1 plus forward impedance into RL2. L2 means the second transistor. Okay, so given is 1 ohm. Is less than 0.1. So will you substitute this one? You'll be getting the value is nearly 256 kilo. So why you have to calculate the internal resistance of the second transistor? We have to calculate the voltage gain. Generally, voltage gain formula is output voltage divided by input voltage. For this case, the output voltage we don't know, input voltage also we couldn't calculate because they are cascaded one. So the previous stage output once you know means they easily will substitute over there. So another way to calculate the voltage gain is that is 1 minus internal impedance Hi divided by internal resistance of a second transistor. Internal resistance of a Ri2 we don't know, so we are going to calculate Ri2 initially. So Ri2 is we obtained the value is 256. Once we calculated this value Ri2, so simply substitute and get the value of the second transistor voltage gain. Yeah, I have calculated and substitute over there, and I am getting that second transistor voltage gain. We are getting the value is 0.996. Right. So once you calculated AV2, they asked to find the value of AV1, AV2, and overall voltage gain. Right. So is it easy to understand? Are you facing any difficulty?
Easy to understand.
You have to remember the voltage gain means A suffix V. So generally the voltage gain is calculated output voltage divided by input voltage. But in this case, the output voltage also we don't know, input voltage also we don't know. So what we have to do? We might be calculate the voltage again another method. That is the 1 minus Hi divided by Ri2. Ri2 means Hi means internal impedance and R is the internal resistance. So by using these two values, we have to calculate. So Ri2 is unknown value. Once we have to calculate Ri2, then is easily substitute over there. That formula is given. Using the formula, we are going to calculate Ri2 and substitute the value here. You'll be getting that voltage gain of your second transistor. We are getting voltage gain of a second transistor is 0.996. Next one, we have to calculate load resistance for your first transistor or L1. Or L1, which is nothing but, will you please look at the diagram? That is easy way to understand because the diagram is playing major role. Here what I'm going to do, I'm going to calculate load resistance of a first transistor here. Okay. Load resistance of a first transistor. Look at that. Resistance of a first transistor and Ri to internal resistance of the second transistor. Both the things are connected in parallel. we are going to calculate RL1. So RL1 is the nothing but 10 kilo ohm parallel with the RI2. RI2 we have calculated 256. 10 kilo ohm, then from the diagram we are observed. So 10 kilo ohm parallel with the 256. Will simplify that R1 parallel with the R2. We know that R1 R2 divided by R1 plus R2. That formula is, you know, that when the two resistors are connected in parallel, we have to calculate the equivalent resistance, that is the product of the two resistance divided by sum of the resistance value when the two resistors are connected in parallel. Right. So we'll be getting that load resistance of a first transistor is, because we are going to calculate voltage gain at the first level. That value is 9.36 kilo ohm. Then already we have calculated output impedance and RL1. Will you multiplying these two categories? Output impedance they are given, RL1 now we have calculated. RL1 is 9.36 we have calculated. Output impedance they are given the problem itself, that is 10 to the power of 1 kilo ohm, I think so. I will remember that output impedance 10 to the power of minus 8. So 10 to the power of minus 8 into this 9.36, you will be getting that value is less than 0.1. So once it is less than 0.1, what we are going to come to know that current gain of your first transistor, that is a common emitter. So negative sign must be there. Is a 50 times of your H value of forward characteristic of a H parameter, H of V. Okay. H of V is they are given the problem itself. Then RI1 we have to calculate. RI1 is equal to HI1, that is given the problem itself. So simply substitute over there, easily way to calculate a value of your current gain, because that common emitter, your current gain is a negative 180-degree phase shifted, that is we know that. Okay. Then I am going to calculate your voltage gain of a first transistor AV1. Voltage gain can be calculated in two methods. One is output voltage divided by input voltage. Another method for your common emitter configuration. That's important. The formula will be we might be use two formula to calculate AV1. One is AI into RL1 divided by R1. AI means we have calculate minus 50 into HFE, and RL1 we have calculated 9.36. RI which is equal to HIE, that is 1 kilo ohm. Will you substitute, will you get some value. Or okay, they are given the formula, that is minus HFE RL1 divided by HIE. What is HFE? That is 50 times of that one. Here they mention as minus 50 into HFE. Yes, minus 50 into HFE. That is the AI. AI is nothing but minus 50 into HFE RL1 divided by RIA. Yes, minus 50 into HFE divided by 1 kilo ohm. That is RI. RI is nothing but HI, input impedance. The H parameter input impedance. Okay. We will getting the values in negative. So first transistor voltage gain is a negative sign. A common emitter, obviously you will get that negative sign. 180-degree phase shifted. No, that's why we are getting a negative sign. Minus 481.5. That overall gain, the overall gain is AV, the product of AV1 into AV2. So AV1 we are getting the value is 0.482, and AV2 we obtained earlier 0.996. Will be product of these two win, you will getting the negative sign again, that is 480. This is the overall gain. That's all. They are asking to calculate AVS, the voltage source of it. That is that formula is overall voltage gain into RS divided by RS plus H0. RS is they are given the source resistance from the diagram. Will you please look at the diagram? You will come to know the RS they are given is 1 kilo ohm. By using the value only, will be calculated AVS, the voltage gain of your source. So overall voltage gain into source resistance 1 kilo ohm divided by 1 kilo ohm plus H0, that is also 1 kilo ohm. So you will getting 2 kilo ohm. The overall voltage gain of your source voltage is minus 240. Okay. So this is only they asked from your problem. The problem is, I will read again. They asked to calculate AVS. AVS, it is nothing but voltage gain at the source side. Voltage gain at the source terminal. So please remember, AVS is the voltage gain at the source terminal. So AV1 is the voltage gain at the first transistor. AV2 is the voltage gain at the second transistor. So these three things we have to calculate. So I am taking as a common emitter is a first transistor, common collector with a negative second transistor. So common emitter means you will get a negative sign. So common collector we are taken as initially to calculate AV2. I have calculated AV2 is 0.996. Once you know that the value of AV2, will you please proceed that calculate the AV1. AV1 is also we are getting negative sign minus 481.5 taken as approximately 482. So once you have these two gain value, the product of these two one, that is the overall voltage gain. But the source voltage gain, which is nothing but source based on your source resistance. So we have calculated the source resistance. So based on your source resistance, we are going to calculate your voltage gain at your source terminal, that is nearly minus 240. So will you please stop that overall gain is minus 280? That is a wrong answer because they are asking to calculate voltage gain at the source terminal. That is using this formula, you have to do it. Okay. So they are given three resistance in the diagram. One is source resistance. We are using that last point, and that collector terminal we are using while calculating RL1, and RL2 we are using to calculate a second transistor voltage gain. So all the values we are using. Okay. So please remember, this is one of the important problem. This kind of problem might be expected in your university also, because two transistor, the parameter is given, they have to calculate voltage gain. You are having any difficulties? Are you facing any difficulties understanding this problem?
No, sir.
So please be remember, the formula be different based on your type of configuration. That is first thing. Second one, again you will have two formulas. H parameter only, H naught is the output, HR is the reverse characteristics, HF is the forward characteristic of a H parameter. Okay. So these four values, using these four values, we are going to find output voltage gain, voltage gain, current gain. Okay. And some places they will ask to calculate Z0 and ZI, output impedance and input impedance. Shall we move to the one more problem? Is it convenient to you?
Yes, sir.
Basically, that board will come to know your expression and all. Again, we have to clarify any doubts because it's a virtual classroom. So using that slide, I am clarifying your doubt. If you are asking any clarification, then I will clarify your doubts. So again, I am saying, please make practice, because simply I am sharing, I am showing some document. If you are observing somewhat easiest one, but while solving the problem, you'll come to know what are the parameters, how we are changing the formula, why we haven't get confused this one. Because will you please, in this screen they are taken as AV1 is equal to minus HFE RL by RI. That's the general formula. So why taken as that the input current gain into RL by RI. The current gain value is 50% of your forward resistance H parameter value. Okay. Minus 50 taken as based on your common emitter configuration. So this value, it won't be similar for common collector. The common collector current gain is different from this one. Then we'll move to that one more problem. This is not a cascaded one. This is only a single stage, only one stage be there. In this stage also, in this amplifier also, they are asked to calculate current gain. AI is current gain. AV means voltage gain. AVS means source voltage gain. R1 and R2 for the common collector. So common collector means there will be no negative sign. Easiest one. For a single stage transistor amplifier. Okay, they are using transistor with the parameter as parameters values are given. HIC, because common collector, that's why they are using the term is HIC. The last term no need to worry about. We have to know only HI. HI is 1.1 kilo ohm. HR is 1. HFC is 51 minus 51. H naught is 25 microampere per volt. Microampere means 25 into 10 to the power of minus 6. We remember. And also they are given RS, source resistance and load resistance, because only one stage is there. No, that's why they are given that source and load resistance is 10 kilo ohm. So what they are asking to calculate the important four parameter. current gain, voltage gain, and overall source gain, and input resistance and output resistance for your common collector configuration. So we are going to solve the problem. First, I am going to calculate current gain. So current gain formula is minus HF divided by 1 plus H0 into RL for your common collector configuration. So please be remember, every configuration your formula be little bit changes be there. So you have to remember the formula. The problem is given is a common collector. So common collector current gain is HF forward H parameter value divided by 1 plus H given as 50 input resistance or source resistance and load resistance are 10 kilo ohm. So you'll be getting 10 to the power 4. So will you substitute, you'll be getting that voltage gain, current gain of your given common collector configuration is 40.8. Next, I am going to calculate voltage gain. So they are given that this is a voltage gain. So voltage gain generally formula output voltage divided by input voltage. Output voltage not given, input voltage also not given. So we are going to calculate the help of your current gain. Current gain is Ri divided by load resistance divided by input resistance. Load resistance and input resistance. So load resistances they are given. Input resistance we have to calculate. And current gain we have calculated earlier. So that is 40.8. So input resistance I have to calculate. So I am going to calculate input resistance. Some cases input resistance is equal to input H parameter input. So here that because that product of that value is less than 0.1 only, that condition will be applicable. So here input resistance is HI, that H parameter input plus HR reverse parameter into AI into RL. So here RL is given, AI calculated, HR is given, HI is given. HI is 1.1 in kilo ohm and HR is they are given as 1 and current gain is we have calculated 40.8, load resistance is 10 to the power 4. So will you substitute this value, you'll be getting that input resistance is nearly equivalent to 409.1 kilo ohm. That is input resistance Ri. Input resistance different from RS, that is the source resistance, this is input resistance. Okay, so please be remember. So we are getting the value is 409.1 kilo ohm. Then I am going to ready to calculate voltage gain with the help of current gain value. Current gain into RL divided by R1. Load resistance divided by input resistance. Load resistance is 10 to the power 4. Input impedance is input resistance is 409.1. You'll be getting that voltage gain 0.998. And overall source voltage, that is the voltage gain into Ri divided by Ri plus Rs. So that problem they are given Rs divided by Ri plus RL. So here the Ri, but because here Ri is playing a major role as compared to Rs. Rs is only 10 to the power of 4. Here is 409 kilo ohm. So based on that we are going to calculate input resistance. Already we have calculated Ri and Rs is given. So simply substitute over there. We'll be getting overall gain at the source terminal is 0.97. That is also less than that one. Okay, 0.974. And finally, what you have to calculate? We have to calculate R naught because Ri is already calculated. So R naught only we have to calculate. The formula for R naught in your common collector is 1 whole divided by H naught minus HF HRE divided by HI plus RS. All H values are given and source resistance also given. So we are going to simply substitute in the formula 1 whole divided by where H naught value is 25 microampere per volt plus the product of forward and reverse by 51 into 1 divided by and input 1.1 10 to the power of 1.1 into 10 to the power of 3 yes 10 to the power of 3 and they are taken as wholly 10 to the power of 3 and plus 10 kilo ohm. RS is 10 kilo ohm, so they are taken commonly 10 to the power of 3. So you'll be getting 1.1 plus 10 into whole to the 10 to the power of 3. You'll be getting that finally your output resistance is 217 ohm. So this is the way we have to calculate that required parameter. So they are asking to calculate current gain AI and voltage gain AV and voltage gain at the source terminal AVS and input resistance RI and output resistance R0. So all the values we have there. So this kind of problem only will may expect in your university examination. This is I am showing at sample. Simply that the given values we substitute in a formula will get the output. So this is the way be ready for your attend the examination. Okay. I think this class we are discussing the problem based on your cascaded amplifier and also at single stage common collector amplifier. Okay. So this will very helpful to find that voltage gain, current